Okay, this is my worked out solution of the study guide for test 2. So we're going to begin with the first question. Determine whether the graph can represent a normal curve if it cannot explain why. As you can see, this is not a symmetric curve, and it's not a symmetric curve. That's skewed right. It cannot represent a normal curve. So the answer is no to this one. Number 2, the weight of 2-year-old Hyraxes is known to be normally distributed with the mean of 2,200 grams and standard deviation of 365 grams. Draw a normal curve with the parameters. So this is how you draw the normal curve. The horizontal line. And this is a symmetric curve. You put the mean in the center, which is 2,200, and then you scale it just like that, so that you add a 3 standard deviation, and then you subtract this 3 standard deviation. The standard deviation is 365. So if you add 365, that will be 2,565. And then if you add another 365, you will get 2,930, and then you add another 265 here, and then you do the same for the other side. Subtract 365, subtract 365, and then subtract another 365. This is how you draw the normal curve. Second question, shade the region that represent the proportion of Hyraxes who weighted more than 2930. Well, more than 2930 means to the right of 2930, so that would be this region right here. So that would be the answer to this part. And C, suppose the area under the normal curve to the left of x equals 2930 is 0.0228. Provide 2 interpretation of this. And actually, there is a mistake here. It should be to the right. Because as you can see, the area is very small. It can't be to the left, because if this is to the left, it's a huge area. And here he says it's only 0.0228. So there are 2 interpretations of this. You can say that the proportion of Hyraxes who weigh more than 2,930 grams is 0.0228 or 2.28%. Or you can say the probability of selecting a Hyraxes at random whose weight is more than 2,930 grams is 2.28%. So that's number 2. Number 3, find the area under the standard normal curve to the left of z equals 1.5. I'm going to show it to you here, but then we're going to use the calculator to find it. This is the standard normal curve. That's z, that's a 0, and that's 1, 2, 3 here. And that's -1, -2, -3. So we're using the standard normal curve. Why? Because it says z here. So we want to the left of 1.5. This is 1.5 right here, and we want this area. As you can agree with me, guys, it should be more than 50% because I shaded more than 50%. Here's how we do this using the calculator. For the sake of using the calculator, you need to identify 4 things: the left bound, the right bound, the mean, and the standard deviation. The left bound is what borders the area from the left. As you can see, this curve extends forever here. So it's actually the left bound should be -infinity, but instead of -infinity, in order to put something in the calculator, we put -1,000,000. The upper bound will be where the area ends. It ends at 1.5. So that will be the lower bound, and that would be the upper bound. The mean is 0. For z, the mean is 0, and the standard deviation is 1. So if I bring the calculator in and show you how to do that, here's how you do it. You go to Second, distribute normal CDF, negative 1,000,000, put as many zeros as you want, 1.5, comma 001, paste. If you have an older calculator, it's gonna display normal CDF and open parentheses. So you put the lower bound, which is negative 1,000,000, then 1.5, which is the upper bound, 0.1. And remember, when you use a negative sign, make sure that you use this sign right here. That's the negative sign. And then if I hit enter, and that should give me 0.9332. That would be the area. Next question. Find the area under standard curve to the left of Z is 1.25. It's exactly the same, but instead of 1.5, we'll put 1.5. So it's going to be normal CDF, negative 1,000,000, 1.2501, and then you use your calculator to find this answer. For 5, find the area under the standard normal curve to the right of Z equals 1. Okay, to the right of Z equals 1, let me sketch it here so you can see it. This is how it's going to be like. This is 0, that's 1, and we need to the right of 1. So that's Z equal. You guys agree with me that this area should be less than 50% because I shaded less than 50%. Okay, the left bound will be 1. The upper bound will be infinity. So we just use 1,000,000, and then the mean is 0 and standard deviation is 1. So for number 5, it will be normal CDF. And then 1 is the lower bound, 1,000,000 is the upper bound, 0 and then 1. And let's see what the calculator gives us. Second, variables, normal CDF, 1,000,000, put as many zeros as you want, and 0.1587. You need to round to 4 decimal places. Okay, next question, 6. Find the area under the standard curve between negative 1.5 and 2.5. That should be an easy question, guys, because he gives you the lower bound and the upper bound. So the answer will be normal CDF. Put the lower bound, which is negative 1.5. Put the upper bound, 0, 1. Now, if you are to use the table here, guys, you will have to go to the table and find the area to the left of 2.5, and then find the area to the left of negative 1.5 and subtract the two areas. But if you use your calculator, you can do this in one shot. You don't have to worry about that. And if you just want to know what the answer is, so it will be second, distribute normal CDF, negative 1.5, oops, negative 1.5, then 2.5, 0.1, 0.9270. All right, number 7. Determine the area under the standard normal curve that lies between, same thing, guys, normal CDF, 0.3, 1.4, 0 and 1, and then you get the answer. Assume that the random variable x is normally distributed with the mean is 60 and standard deviation sigma is 16. What's the probability of x less than 80? I'm going to show you how to do this. Okay, let's show you a visual what we're doing. Okay, this is not the standard normal curve. This is the normal curve because now we're working with x, not z. So the mean is 60. That's the mean, 60. And we need probability of x less than 80. So 80 should be more than 60, and we need this area right here. Okay, so that would be normal CDF. If you're watching this video, we need the lower bound, and the lower bound is right here, negative infinity. That's negative infinity. And what did I say earlier? We use negative 1,000,000. Upper bound will be 80. And then the mean is 60. See, no 0, 1 here because we're working with x, and standard deviation is 16, and let's see what the answer is. Negative a million, 80. I think the answer should be more than 50% because I shaded more than 50%, as you notice. And then 16. 0.8944. Now, if you are to use the table, guys, you will need to change 80 to a z-score and then use the table to find the area to the left of z. So you would have to change 80 to a z-score, 80, the value, minus the mean, which is 60, and then divided by 16. And that will be 20 divided by 16, which is 1.25. And then you will have to go to the table to find the probability of z less than 1.25. And it should give you the same answer, 0.8944. But if you use technology, it's a lot faster, and you are allowed to use technology throughout. Okay, that's 7, 8. Let's go to exercise 9. And we'll continue from there. 9. A physical fitness association is included the mile run in its secondary school fitness test. The time of this event for boy in secondary school is known to possess a normal distribution with a mean of 450 seconds and a standard deviation of 50. Find the probability a randomly selected boy in secondary can run the mile in less than 335. So we need a probability of x less than 335. Okay, that would be normal CDF. If it is a less than, guys, you have to begin with negative a million. Then your upper bound will be 335. And then the mean, it's not 0.1 again. So that's 450. And the standard deviation is 50. And let's see what we come up with here. Second, distribute, normal CDF. Okay, upper is 335, 450, 50. And the answer is 0.0107. Again, if you don't want to use technology here, you need to change 335 to a z-score and then use the table to find the area. The length of time it takes college students to find parking spot in the library parking lot follows a normal distribution with the mean of 6.5, so that's the mean, and a standard deviation of 1 minute, that's sigma. Find the probability the randomly selected college students will take between 5 and 7.5 minutes. That should be an easy question, guys, because it's in between. You already have the lower and the upper bound. So that would be normal CDF 5, 7.5. The mean is 6.5, and the standard deviation is 1. And let's use the calculator to find this one right here. Second, distribute. You see how many times we use the normal CDF? It's a very important feature. 6.5 and then 1 and then run. And the answer is 0.7745. Next question. Number 11, a firm believes that the internal rate of return for its proposed investment can be best described by a normal distribution with mean of 36% and standard deviation of 3%. What's the probability that the internal rate of return for the investment exceeds 42%? Exceeds 42%, guys, means the probability of X more than 42%. Okay, so that will be normal CDF. Okay, more than, so you begin with 42%. So that's a 42%, which is 0.42. Then million, because there is no upper bound. So when you do more, you start with the number, put it here, and then the next one should be a million or trillion. Just put as many zeros as you want, and then put the mean, which is 36%, 0.36, and then put the standard deviation, which is 3%, 0.03. And let's see what the answer is. Second, distribute, normal CDF. So I got 0.42, 1 million, 0.36, 0.03. So I got 0.0228 as an answer. All right. Now, could you have used 36 instead of 0.36? Yeah. If you put 42 and then you put 36 and you put 3, it should work as well. Find the z-score for which the area under the standard normal curve to its left is 0.04. So here is what he wants. I'm just going to show you what he's asking us to do for number 12. There is the standard normal curve. He's given us an area of 0.04 on the left. So this area is 0.04. And he wants this value, z. So we're doing the reverse of what we were doing. Before, in questions 1 through 11, he gives us the x value and he wants the area. Now he gives us the area and wants z. In order to find z, you can use the table. You go inside the table and look for the area 0.04, or easier, we can go to the calculator and do inverse norm feature. Inverse norm, guys, requires, in order to find z, it requires that you only provide the area to the left of the target, which is 0.04. And it requires the mean and the standard deviation. And the mean is 0 and the standard deviation is 1 since we're working with z. So let's find this z value. So this is the second calculator feature that you'll be using in this chapter, inverse norm, 0.04. It's going to be negative because it's on the left, negative 1.75. That's the z-score. Next one, 13. Find the z-score for which the area under the standard curve to its right is 0.07. Now the area to the right is 0.07. Let me show you. Now we have to shade to the right. This area is 0.07. Okay, I need this z. And that's 0 right here in the center. That's a z line. It's going to be a positive z-score. Well, as I told you, the inverse norm requires that we provide the area to the left. If it is 70% on the right, how much would it be on the left? Would you agree with me if I tell you 93%? Because the total area is 100%, which is 0.93. So you put 0.93, comma 0, comma 1, and you should get the z-score. It's 1.48. If you round to 2 decimal places. Okay, so that's number 12, 13. Okay, next. 14. Determine the z-score that separates the middle 87.4% of the distribution from the area in the tails. Okay, let's do this one. Okay, here is how you do this one. This is the middle 87.4% right here. We need this z-score and we need this z-score. There are 2 values here. Okay, here's how you do it. Total area is 100%, minus 87.4% will be 12.6%. Split the 12.6% on both sides. So this is going to be what? 6.3%. And this is going to be also what? 6.3%. Let me show you how to find the first Z. You go inverse norm. You need the area to the left, which you already know 6.3%, so 0.063, and then comma 0, comma 1. You find the first one. It's going to be negative. The second one is going to be positive, Z2, and it's going to be the total opposite. Okay, if the area on the right is 60.3%, what would be the area on the left? Not 87.4, it's 87.4 and 6.3. So it's gonna be 93.7%. So it will be inverse norm. 93.7, you do it 0.937, comma 0, comma 1. And if you want, I can show you how to use a calculator here. 0.063, negative 1.53. And guys, you should know that this is going to be 1.53. 0.937. There you go. Same thing, but positive. So these are the two Z-scores. And that was number 14. Okay. 15. Assume that the random variable X is normally distributed with a mean of 15 standard deviation of 12. Find the 24th percentile. Okay, let me tell you what we mean by 24th percentile. 24 percentile, 24%. You just shade the 24% at the very beginning. So this is 0.24 area. And we need this X value right here. Okay, in order to find this X value, you go inverse norm. Now it's X, not Z. You find the area to the left. So when it is a percentile, guys, you just use whatever the percentile he gives you as the area. So that's going to be the area right here. So 0.24, comma, the mean, not 0, 1. We're working with X now, comma 50, comma what, 12. And let's see what the answer is. Second inverse norm, 0.24. 50. It's going to be less than 50 because the mean is 50 right here. That's the mean, 50. So it will be X less than 50, of course. 12. It's 41.52. Next question. A physical fitness association is included in the MyRun in the secondary school fitness test. The time for this event for boys in secondary school is known to possess a normal distribution with the mean of 440 seconds and standard deviation of 50 seconds. The Fitness Association wants to recognize the fastest 10% of the boys with certificate. What time would the boys need to beat in order to earn a certificate? Okay, here's how we do this one, number 16. Draw the normal curve. Oops. Okay, the mean we said it's what, 440, and standard deviation is 50. Okay, where do you think, guys, the top 10%, fastest 10% is going to be? Is it going to be on the right or on the left? Well, the answer is on the left. Although top usually goes to the right, but for a race, the lower the time, the better. If you finish the race in less time, then you're better. So it's going to be fastest, so the ones who finish in less time. So we're going to shade the 10% right here. That's the area. And that's the X that we need. And in order to find the X, you go to inverse norm. You put 0.10, which is the area. You put the mean, which is 440, and you put the standard deviation, and that should give you the X value. And it turns out, if you use your calculator, it will be 376 seconds. So students who finish in 376 seconds or less will be eligible for the certificate. All right. 17. A brewery has a beer dispensing machine that dispenses beer into the company's 12-ounce bottles. The distribution for the amount of beer dispensed by the machine follows a normal distribution with a standard deviation of 0.10 ounces. The company can control the mean amount of beer dispensed by the machine. What value of the mean should the company use if it wants to guarantee that 98.5% of the bottles contain at least 12 ounces, the amount on the label, round to the nearest thousands? So how do we do this one? All right. So he didn't give me the mean. I need to find the mean here. And he says they want to guarantee that 98.5% of the bottles contain at least 12 ounces. So here's how we do this one. That's fine. So this is what we want. We want 98.5% of the bottles to contain at least 12 ounces. Okay, what I'm going to do, I'm going to find, first of all, this value right here, the Z value, and then use the formula of the Z score to figure out what the mean is. So if I go to inverse norm and I put 0.985, comma 0, comma 1, I will get 2.17. Now, guys, we have this formula for Z, X minus mean divided by sigma. So X will be Z times sigma plus the mean. If you take Z, which is 2.17, and multiply it by the standard deviation, which is 0.1, that should give you what? 0.217. And if you add 12 to it, which he says at least 12, so it's 12 plus 0.217, that should give me 12.217, and that's the value that we are looking for. 18, determine, now we're talking about the distribution of the sample mean. So we're working with samples of size n. Determine mu x bar and sigma x bar from the given parameters of the population and the sample size. Mu of x bar, guys, when you work with samples, it is the same as the mean of the original population. And sigma of x bar, which is called the standard error of the mean. So if I ask you to find the standard error of the mean, it's sigma of x bar, which is sigma divided by square root of n. So mu of x bar will be the same as the original mean, which is 28. And the standard deviation will be the original standard deviation 8 divided by square root of 22. And if you do the math for this one, for number 18, it will be 1.706. Okay, next question. I'm gonna go to 19. What are the values of mu x bar and sigma x bar for the sampling distribution of the sample means? And actually, this is x bar right here. This should say x bar. So you already have the graph of the sampling distribution. As you can see, mu of x bar, you can read it, is simply 8. Sigma of x bar, how much did we increase 8 to get the 8.04, which is a 0.04, and that's the standard deviation. So if you want to know what the next number will be, 8.08, add 0.4. Then the third standard deviation, 8.12. 7.96, subtract 1, subtract 0.04 will be 7.92, and here will be 7.88. But remember, this is X bar, the distribution of the sample mean. 20. The number of violent crimes committed in a day possess a distribution with the mean of 2.2 crimes per day and a standard deviation of 6. A random sample of 100 days was observed, and the mean number of crimes for the sample was calculated. Describe the sampling distribution. So the distribution of the sample mean is always approximately normal. So with a mean which is the same as the mean of the original population, which is 2.2 crimes per day. The standard deviation, guys, is going to be a lot less. It's sigma over square root of n. So it will be 6 divided by square root of 100, which is 6 divided by 10, which is 0.6 crimes per day. 21, the average score of all golfers for a particular course has a mean of 75 and standard deviation of 4.5. Suppose 81 golfers play the course today. Find the probability that the average score of the 81 golfers exceeds 76. So here he wants not the probability of X, the probability of X bar. How do I know? Because it says average score, the mean. I could have said the mean score or the sample mean score. Exceeds means more than 76. So that will be normal CDF. What's the lower bound? 76. What's the upper bound? 1,000,000. What's the mean, which is the same as the original population mean, which is 75. But guys, here you have to pay attention. When you work with the sample mean, the difference between working with one individual and a group of individuals, which is 81, that when you work with a group with the sample, your standard deviation will not be sigma, will be sigma over square root of n. So you take the standard deviation of 4.5 and divide it by square root of 81. And let's see what the answer is. Let me show you. Turn the calculator on. Second, distribute normal CDF. So it's more than 76. So you put 76 as lower bound. Million, put as many zeros as you want. Doesn't matter. Put 75 here, and here sigma put 4.5 over square root of 81. Close parentheses. 0.0228. The amount of money collected by a snack bar, we're doing 22, at a large university has been recorded daily for the past 5 years. Records indicate that the mean daily amount collected is 4,000 and the standard deviation is 450. The distribution is skewed to the right due to a severe high volume days, including football game days. Suppose 100 days were randomly selected, so that's n sample size, guys, from the 5 years, and the average amount collected from those days were recorded. Which of the following describe the sampling distribution of the sample mean? So that should have been a multiple choice, but I'll give you choices, but let me tell you what would that be here. When your original population is not bell-shaped, what can you say about the population of the sample means? It will be bell-shaped if the sample size is more than 30. And as you can see here, guys, the sample size is 100. So the distribution of X bar is normal, symmetric. And what's the mean? Mean of X bar will be the same as the original mean, which is 4,000. But the standard deviation, guys, it's going to be 450 divided by square root of 100, which is 45. So in other words, here is one thing to be aware of. In other words, this is the distribution of X. If I ask you to draw the distribution of X bar, guys, let's say the mean here is 50. You would draw exact same curve with the mean of 50, but watch what's going to happen here. This is X bar, sample mean. You notice this curve is wider, more spread than that one. This is narrower because the standard deviation of X bar is always smaller than the standard deviation of X. Here, the standard deviation is sigma. Over here, the standard deviation is sigma over square root of n. So that's why it's good to work with samples, because we get smaller standard deviation, so we have more consistency in this case. 23, a farmer was interested in determining how many grasshoppers were in his field. He knows that the distribution of grasshoppers may not be normally distributed. So if the distribution is not normally distributed, he has to pick a sample size of more than 30. As he drives his tractor down each row, he counts how many grasshoppers he sees flying away. After several rows, he figures that the mean is 57 and the standard deviation is 12. What's the probability the farmer will count 52 fewer flights on average in the next 40 rows? So n is 40. So we want probability. Once he says average, it's X bar. 52 or fewer means less than or equal to 52. So that will be normal CDF. Okay, for less than, guys, we agree we begin with -1 million. And then we put 52, then we put 57. But the mistake that students make here, they put 12 here. It's not 12, it's a question about the sample mean. So it's 12 divided by square root of the sample size. And if you do the math for question 23, you should get 0.0041. I will stop the recording here. That's for sections 7.1, chapter 7 and section 8.1, and then I'll do another video for the next chapter. All right.